Welcome to Donuts, Design, and Debate, the podcast where we discuss and you decide how many coveted donuts a particular design receives. I'm your host, Matt Robison, and what are we talking about today, Aaron?
Today, we're going to dive into the world of 3D printed structures.
Ooh, baby, 3D printed structures. Now, we're not talking about just any 3D printing, any structures. We're talking about structures, certainly, but not the desktop, tiny structures, scale models or anything like that. We're talking about practical, habitable structures, not experimental or conceptual ideas, but things that actually work as a structure is intended to work in the real world.
That's right. We're actually like things you could go in and live in, or they can keep you up off the ground. Not your hobby 3D printer, but this is like the big stuff. Concrete or clay printed structures. We got to backtrack and give you props on habitable. That was that was like 10-cent word right there. I appreciate that. Habitable 3D prints.
Habitable? It's a lot of syllables to
I was going to say go inable, but habitable probably better word. We should lean that way.
Yeah, for sure. So we're definitely talking about commercial and residential construction. We're talking about civil construction, bridges and other type of usable structures in the real world.
That's right.
And I'm going to run down a little bit of the history here, and Aaron certainly chime in if I leave anything out or miss anything. Also, I should mention that on the line as well today is our producer, Aubrey. So she's there in case you hear another voice.
I had to unmute myself there. Hi, everyone. Here we go.
People are used to it from working remotely, certainly. So no sweat. Cool. So if you hear a third voice, that's who else is chiming in here today. So the history of 3D printed structures. Looking back, I think slip form kind of concrete placement is sort of the grandfather or the proto work of this kind of printing. Slip form is pouring concrete in layers, and then as it dries, pouring the next layer, and then it adheres to itself. I saw this really cool video from the 30s. It was 1937. This farmer had created his own slip form kind of thing to build a silo. So it's an arm that's on a central pivot point, and then they're just loading concrete in and one layer at a time kind of spinning it around. So that's not fully autonomous, but still a cool application, and sort of you can see where it branched into what it is today.
The predecessor of modern 3D structure printing.
Exactly, predecessor. There's your 10-cent word.
Got one.
Fast forward a little bit, the more automated part of it started to come in sort of 80s and 90s in Japan. So this is definitely still the slip form technology and process, but is more automated. Unfortunately, never really took off and never really got implemented at a large scale. In the 90s, there was a company called Contour Crafting that had a patent in 95 for a more autonomous process using extruded concrete to create structures. In the 2000s, it was definitely more university and sort of experimental projects, definitely prototypes and proofs of concept for what could happen, but wasn't really being used for anything like we talked about, a usable, habitable structure. Get into the 2010s, the mid-2010s is really where there's this sort of boom in production. A lot of companies are taking this design problem on and trying to solve it. There's two main systems that are used for this kind of additive manufacturing. Gantry system, which uses a printer that's on rails, similar to like you see on a desktop 3D printer. It's on rails and it goes back and forth and lays out material in XYZ coordinates. Or robotic arm control system that works with polar coordinates to, it has 6 axes and can move around and place material based off the existing material that's there one piece at a time, kind of. So there's three main kinds of this kind of 3D printing. There's extrusion, which, like I mentioned, is a straight up concrete, laying it down one layer at a time, and it adheres to itself. Powder bonding, which is a polymer or reactive bonding or sintering, where heat or chemical is applied to this powder to reacts with it and creates a structure that way. And also additive welding, which is applying weld and building it that way. So like I mentioned, in the mid-2000s or mid-2010s, pardon me, there's this Chinese company WinSun that was doing a lot of larger scale single-family homes. They did a 6-story apartment building, sort of a larger home as well. Dubai, there was the first 3D printed office building in 2016. There's a pedestrian bridge in Madrid that went up in 2016. And 2017, the last of these examples, there's a cycle bridge that went up in Amsterdam across a little canal that people can bike over. And one thing that I found was interesting, reading one of these articles, it said that the distinction between material and structure is fading. So it's kind of a cool concept of being able to use the material as structure. And a couple rogue points here. There's also the process of using a wax-like material and 3D printing that, and then filling that cast with like a concrete material, and then afterwards melting down the wax and then reusing that, which I thought was cool. One other point is that Dubai apparently hopes to 3D print 1/4 of its new structures by 2030, which I feel like is an ambitious goal, but admirable if you like 3D printed structures.
You talk about ambitious architecture. That's the place that really, literally lives for that.
Yeah, taking it to the next level. And I felt like the implementation of these kind of technologies was interesting, or at least the future ideas of, anytime you need a quick structure put up, like rebuilding after natural disasters, or I saw a lot of implementations being used for like barracks in war. You're on site, you need a quick building, this kind of thing. I saw there was an old fountain in Russia that got, sort of repaired, rebuilt with 3D printing built onto the existing structure, which is pretty sweet. And then the last part I have here on the history is 3D printed coral reefs, which some companies are doing to help restore ocean and marine life. So it's definitely mainly thought of in sort of residential and these little bridges and stuff is what has been used for so far, but the opportunities are pretty inspiring, I think. So a little bit of the rundown of the history. Did I miss anything there, Aaron?
No, I mean, when we looked at it, the thing that blew me away is how long ago this technology kind of started, like the 50s. Like that blew my mind to think that there was, and it was basic. I mean, it was a gantry arm spilling thick concrete in a very intentional manner. But like, I think about 3D printing, FDM printing, we're melting plastic in the same way, and think maybe 20 years, like something like that. Like to think that this was 70 years ago, they were doing it with concrete. That was crazy to me. That was like an insight that I did not expect. But
yeah, it's like they had the idea, they just didn't have the technology infrastructure in place to scale it up massively. But it's cool to see people just using what they have to be like, I wonder if we can do this, and then creating some cool stuff with it.
That's awesome. Thanks for that. That is a very, very informative history. So at this point in the show, what we're going to do is Matt and I are going to begin the debate. So we, off camera a couple days ago, flipped a coin, and one of us came up with pro, one of us came up with con, and we are going to take turns giving you the pros and cons of 3D printing. After a couple minutes apiece, we will have a chance for a quick cross-examination. We can go back and refute each other's points. And then what we're doing is we're going to run down our 5 principles of design. I'm going to give you guys those notes in just a second, remind you what the 5 principles are. And what you will be able to do, our audience, if you're listening to this as a podcast later on, I'm sorry, it's too late to vote. But if you're joining us live during the recording, you'll actually be able to cast your vote and help us decide, point by point, if 3D printed structures are good design. So just to have in your mind, here's the 5 points that we've come up with, the 5 principles. Is this design useful? Is this design aesthetically pleasing? Is this design simple? Is this design environmentally friendly, and is this design honest? So keep those 5 points in mind as we go through our pre-prepared points that we're going to bring up right now. Did I miss anything, Matt? Are we good?
That's absolutely right. No, you got it. Nailed it. First try.
All right. 11th try. We've done a couple of these before.
Yeah.
All right. Well, with that, so what we generally do is the pro goes first, so whoever's in favor of the design, and again, unbiased coin flip, that ended up being me. So I'm going to go ahead and give you a couple minutes of why 3D printed structures are good design. That's right. Matt's going to take some notes and realize he has no legs to stand on, and this is going to be our first 5 donut session.
Not a chance. Not a
Let's
chance.
do this. All right.
Okay. Yeah. Take it away. Why are 3D printed structures good design?
All right. Let's talk about that. I mean, I'm going to hit you with the big thing first, right? Building buildings is an expensive endeavor. It takes money to build a building. So on average, a 3D printed structure comes out to 20 to 40% less per square foot than traditional conventional building methods. So right off the bat, we're coming in, and I hate to say it all boils down to money, but and probably should use an argument like that for the end, but let's be honest, when you're building something, if you can save money, that's a good argument for that particular design. I would say that having worked, so this is a personal point, working with builders over the last several decades, they strive day in, day out to find ways to save money and differentiate themselves from their competitors. If you can go in and say that I can create this for 20 to 40% less, immediately that is an enticing design. To that point, another thing that is a huge impact, enormous impact on building right now is the workforce. We have a labor shortage, a workforce shortage when it comes to building. The fact is, building with one of these machines requires fewer people to actually be on site and less knowledge of traditional building or construction practices. Because it's a new technology, it means somebody can learn how to do it and do with less people get more done than traditional building. So kind of a big thing. And again, this is a new technology. This is still up and coming. This is something that, I know we just talked about how it's 70 years old, but really we're putting big energy into this and it's making big steps forward now more than ever before. It's past the point where universities are doing it. It's getting to the point where, like Matt pointed out, Dubai is going to be doing this for office buildings. In the next 10 years, they want a large percentage of their buildings to be built this way. This is something that is stepping forward and is a big deal. One of the things that is going to come up is the appearance of 3D printed buildings. And I mean, I gotta say, they are unique looking. They do look different from other. It's not a traditional siding or stucco building. It does look different. But is that a bad thing? Is this moving forward? I mean, is having something that doesn't look like your neighbor's house or doesn't look like a normal house, is that something we would hold against a new type of building? I think it's something that we could really lean into. Brutalism is something that we're seeing more and more coming back, those stark structures. And I got to say that 3D printed structures fit pretty well in the brutal aesthetic. So something to keep in mind as we develop an opinion of this particular technology. It's also pretty incredible that I just got to say that the fact that you can set up a machine and as long as you're pumping material to it, the machine does the work. So this actually ends up leading to quicker turnaround on simple buildings as well. So where traditional frame might take, a dozen guys a week to put up, a concrete pump and 2 or 3 people maintaining it could potentially put up the same structure in, a day and a half. So something to think about is just like, what are we actually using it for and what can we get out of that? What are the advantages? I'm sure, I'm going to read cards. I don't know Matt's debate. We when we create these points, we work separate, but I'm going to think, I think Matt's going to come up and say, well, but a concrete wall, how are you going to hang a picture? And I just want to throw this out right up front. Yes, America, we're used to wood walls with drywall on the inside of them, and we go find a stud to hang something, but most of the world actually lives in block structures. So the idea of having a concrete structure and all its insulative properties, all of its lateral force resisting technology, concrete is not a bad thing, and I think it's something we should embrace as opposed to be afraid of, because it's different from the way that we do things here in America. Don't be so American, Matt. Come on, open your mind. Free your mind, man. Sorry, I did a little preemptive cross-examination there. Matt hasn't even had a chance to speak yet. Just a couple final points. One of the primary materials used to create 3D print structures is concrete, which is a sustainable material, which is amazing for the environment. It is something we can keep making. It's something that's reusable, renewable, so concrete's a good thing. And the biggest thing I gotta say is it is a new technology, which is scary, but I think the fine listeners of our podcast are ready to embrace change, embrace new technology, and agree with me when I say 3D printed structures are amazing design, like 5 donut amazing. All right, Matt, you're up.
All right, so you claim. I don't know. We'll see about that. But you made some good points, and we'll see which side of history people fall down on. Okay. So for the con, a lot of things we can say here, but I believe in people who build structures. And investing in 3D printing technologies is a gamble, and it's not worth the risk. And I think if you take 2 things away today, those are the 2 things you should take away from my opening argument here. I believe in people. I know you do too. People who build structures. And investing in this 3D printed technology, it's not worth the gamble, folks. I mean, okay, so people have been building structures for tens of thousands of years before 3D printing came about. These are people who built the Eiffel Tower out of metal and brawn. Now, let's not forget, shelter is one of the base needs identified in Maslow's hierarchy. And of course, let's not discount the human ingenuity and engineering prowess that helps keep us and our loved ones safe every single day. From earthquake proofing to that has saved countless lives, to the cross-functional communication, collaboration, and teamwork that has created today's built environment, we have human craftsmanship and expertise to thank for that. Now, this isn't to say there's not room for improvement, of course. Design, after all, is inherently iterative and self-improving. And I think 3D printing has a place in construction, and most rational people would agree with that. But I think 3D printed structures themselves do not have any place in construction. They're bad design. I think additive manufacturing and digital fabrication on a large scale are happening, but when we talk about automation in the construction industry, it shouldn't mean bringing a 3D printer to the site. I mean, that's just impractical and immoral. I think printing constituent parts in a controlled manufacturing environment where the elements can't mess with it, because most of these buildings, you're building them outside, or bridges or whatever it might be. That building pieces offsite and bringing them to site is an efficient process, but we're talking here about building the entire structure with a 3D printed process. And so I think Aaron would definitely have you believe that that is not the case. He thinks you just build them all in place. Okay, fine. And of course, as I mentioned before, investing in 3D printing technology is a gamble. There are multiple risks involved. There are safety and permitting risks. So many of these new projects you read about, they have a great concept and they maybe have some funding and there's tests done, but they never get off the ground because there's a lack of inspection and permitting infrastructure. There are workforce risks involved. How many well-trained professionals are there who can work this technology? How many electricians and plumbers can step in when you have an issue, who are like experienced in 3D printing, like putting electricity through a 3D printed wall, and I think this the automation paradox makes sense to bring up here because this defines this huge problem that the more that a process is automated, there's fewer and fewer people who understand how it works and how to fix it. And the last risk is the risk in the promise of the technology. This is dishonest. I mean, how honest can this tech be if the largest manufacturer, this Winsun in China, that's doing, they're doing 6-story buildings and they claim they can do 10 single-family homes in 24 hours. Okay, but they also don't let anybody see the printer working. They don't talk about any details on the project. It's just dishonest, and there's too many risks with the technology. That what the technology promises, it's just too big of a gamble. Renowned gambler Charles Barkley, in reference to losing over $10 million betting in his lifetime, said that a gambling problem comes in, the problem is when you can't afford it, is what he says. So perhaps this ruler of Dubai has no problem scaling up this type of 3D printed construction, but for almost 100% of construction projects, the risks outweigh the benefits. And I'll have another quote here, of course. In the words of the immortal Kenny Rogers, you got to know when to hold them, when to fold them, when to walk away, and when to run. And I'm here to say it's time to fold them on 3D printed structures. It's certainly time to run. Investing in this process is not worth the gamble. And of course, folks, I believe in people. People build houses, human beings, not robots. And I'm not, here to say, they took our jobs, they're taking our jobs. But like Aaron said, there's a big problem with labor, with workforce in the construction industry. And a big part of that is that this skilled construction workforce is aging out. I think transitioning to 3D printing now is only going to alienate them more from the work, and they're not going to be contributing as much, passing this skilled information on to the next generation. We need skilled, experienced craftspeople. It might be a dream to have a computer retain all this information of this collection of expertise that human excellence can provide, but unfortunately, it's just not realistic. I believe in people. I know you do. And 3D printed structures are just not worth the gamble. And finally, Aaron, your prescription for 3D printing structures on the construction site is not only a misdiagnosis, it's cementitious, it's precocious, it's rambunctious, and it's atrocious. I rest my case.
I don't know if you did, because I don't know what cementitious means. I'm going to assume it means well put, so that's where I'm going to...
Chat, what does cementitious mean?
Yeah, see, if anybody else out there knows, then I don't know. Then I'll know. But
Ooh.
All right. So
what do you got to say to that?
I got a couple things I got to say.
Sure. Fire away.
Barkley? That's your expert opinion is Charles Barkley? Okay.
Hey, he knows a lot about gambling.
He's a very tall guy, so I'll give him that.
I look up to him.
All right. So I mean, just the general idea of we should stay away from something because it's a gamble. That just sounds so non-human. That's. Would we be on the moon? Would we have cures for the sicknesses we have if we didn't, as humans, want to gamble and try to go somewhere we haven't been or haven't done before? It's a new frontier. And I, for one, think that this is where we excel. When we pull together as human beings and we launch into these new frontiers, I think 3D printing is that new frontier that we can launch into. And
but these are calculated risks. This isn't like, there's a promise of something. Going to the moon is a certain thing, but just having 3D printed buildings, it's like we already have buildings.
We're squirting concrete onto another piece of concrete. I think that's we can calculate that fairly well. I agree that, I 100% support craftsmanship. I think, I've worked with builders, architects, my entire professional career, and I have super respect for those kind of people, but what happens when they're not available? What if we're in a location where we can't find somebody who needs to frame, but we could get a 3D printer in there? There's a trade-off there, right? I'm not saying we shouldn't take it away from people, but there's a solution for when we can't get those people to to build. And on that
Sure,
note, I mean,
you can't find a person to frame, but you can find a person who can design with your 3D printing like restrictions and constraints in mind, and can operate the printer and make sure that everything goes well. I mean, the construction
it's so
site
simple.
has
It's like out of the box. It's so easy.
have so many variables. That sounds like coming from a person who's not done a lot of 3D printing. If anybody in the chat has done 3D printing before, you know that turns into a rat's nest. It's coming off the build plate. That's a small scale. Imagine at a huge scale. Like, this is massive problems can go on unless you're watching every single inch of this material be poured. It's not as simple as just click and go and walking away.
But what if it is?
Okay. Yeah, what if I could just snap my fingers and make a house? What if that?
So I do have to, I mean, I have to agree with you on one thing, is that there is an issue, and there will be an issue with anytime we have new building technology, the idea of permitting and inspecting. It's rough. I mean, it is always a slow-going process. I think that is something that it's a reason to move forward, though. It is something we need to push out of. We need to stop doing things the way we do them because that's the way we did them. I think that is a terrible mindset that breaks originality. It stops progression. If we go, well, we have never done something like this, so let's not do it, that's bad. Permitting's hard. Well, let's make permitting better. I think in general, the ability to, use new materials, new technologies in building is something that we need to be pushing forward along with things like 3D printing. So I agree, but I don't think it's a thing to stop for.
This is one piece of the production process. There's different requirements for different things that go into construction, and just saying, oh, we have a 3D printer, let's just do it all 3D printed. Like, it makes no sense. Like, okay, well, I have this screwdriver, so I'm just going to screw drive everything. And it's like, okay, well, traditional construction takes concrete, takes wood or spot welded steel, laminated glass, siding, shingles, roofing, like all this kind of stuff goes into it. And just saying, oh, sure, why not just 3D print it? It's like, that's not approaching a problem with a design mindset. That's just forcing a technique onto a process that it doesn't fit. And I think maybe the time you spend in actual the structure going up, we go back to the permitting. Like, okay, who are you going to find to come and inspect this? How many people on the earth are certified to make sure that this is a habitable structure? It's just not there. I think also you talked about the aesthetics being unique. Okay, fine, they're unique, but it's not due to like a beautiful design, like our architecture way to approach a problem. It's due to constraints and restrictions that the design looks that way. So it's not freedom in design. It's like, okay, this is literally the only way we could do this. So.
Only way right now, like. But as we've talked about, this is something that's moving forward. Look at what's being done with other concrete, tip-up concrete, buildings. Yeah, office buildings started as a bunch of rectangles and they were boring, and now we have technology that's changed, stronger formulas of concrete where we can make shapes and make things that weren't available with the first ones. 3D printing technology can only get better and better. So, yeah, first wave, not the most exciting buildings, but doesn't mean it's not going to be better as it moves forward.
I think the restrictions of doing it on site are just too high. Even like whatever you could imagine doing something in place could be, doing smaller parts that make the most sense in a controlled environment. That's where 3D printing is in the future of construction. It's not bringing a concrete mixer to site and just laying it out through an extruder. Frankly, it's just daft to imagine that.
But see, even there, I mean, I'm ready to get to voting, but I just got to push back and go. On an average construction site, a lot of times you have concrete already. Concrete's already coming on site. You have dumpsters being rolled off. You have cranes coming in to put trusses in. So the idea of another piece of hardware equipment, it's not really that far-fetched to me. I think that, there's definitely a spot, especially if you can knock out, what do you say, like 10 homes in 24 hours? That's worth setting up a little extra
I'll believe
material.
it when I see it. Yeah,
Skeptic.
It's all smoke and mirrors. I don't believe the claims that some of these companies have made. But that's me.
All right. Vote. Let's vote. I agree. All right. So here's how. Thank you guys for sitting through that. Hopefully we swayed you in the proper direction. And what we're going to do now is we're going to have you guys vote. So one by one, our different principles of design are going to come up at the bottom, and you're going to vote right now as the live audience on if each point is satisfied for 3D printing structures. So as we do this, Matt and I are going to get a chance to just throw another jab or two at each other, throw a little more information your way just so you know where we all stand. And we'll do that first with is 3D printed structures useful? Since I just talked, Matt, why don't you go first?
Okay, I certainly can. I think Aaron talked about it being useful for that it's quicker and cheaper. And I think that if it's done perfectly, if everything goes according to plan, but like I mentioned earlier, if you've ever 3D printed before, you know that not every print goes perfectly. And it's one thing to have a mess of plastic, of PLA on your desk, and you can just clean it off and do it again. But if you have an entire half a building went up and then it's a mess of concrete everywhere, that's a problem. I think it's not useful because it's a novelty. It's like the pieces aren't in place that could enable widespread adoption of this. There's not the requirements for, like we mentioned, different permitting. It's unsafe to live in these environments. And I think developers also would be at a lot more risk for liability than they normally would be attributed to human error. So that's something that's unuseful about 3D printed structures design-wise. What do you think?
I'm just going to come right back to, like I said, just keeping it simple as possible. Everything's getting more and more expensive nowadays. It's harder and harder to do things. Building a house is a huge expense. And if using something like 3D print technology can knock 20, 30, 40, 50% off of that process, that's extremely useful. Having a house that's put up in the time, a fraction of the time for a fraction of the cost, I don't know how you get more useful with the technology when in something like home building.
Sure. Yeah. Find somebody who can do it, and you're in luck.
All right.
Good luck.
Well, I don't think I need luck because I think I had the donuts on my side. We did get a donut for useful. One donut out of.
All right. One in the bag.
All right. Up next.
Yes, aesthetics. So you get to go first. Are 3D printed structures a good aesthetic design?
I mean, this is always tough because anytime we get to the aesthetic argument, beauty is in the eye of the beholder. It's hard to say what is beautiful, what is good, what is bad, what looks good, what looks bad. Like I said, look, most concrete buildings, people have strong feelings one way or the other. Brutalism in general, concrete, stark structures. A lot of people don't like them, but it's something different. Seeing a 3D printed structure where you can actually see the ridges, it's something new. I think it's kind of exciting, and I think it's kind of fun. So I think it has aesthetic appeal, even if it's non-traditional.
It's sloppy. It's just frankly disgusting to look at from the outside. I think, look, this technology can be cool, but just not for houses. Don't force it into houses. Like, there's a lot of cool sculptures, and like we mentioned, the bridges. Even if you look at the Madrid Bridge, it kind of looks like not very cool looking, at least to me. Aesthetically, it kind of looks like a slop together, algorithmic design, and it's like, I don't want an algorithm design in my stuff. It looks a little slimy and gross. But aesthetics is not only visible beauty too. I think that in the design process, the aural discomfort that you'll find, this unaesthetic feeling when, we're saving money on labor costs, but that means there's no overtime. So let's run these printers 24 hours a day. If you have a construction site right next to you, you know how annoying it is. And then if you ever sat next to a 3D printer, at work, I used to sit next to a 3D printer. Yeah, that's fun. That's aesthetic to me. We hear that all night. Okay, not aesthetic. Over.
All right, no donuts for aesthetic. I'm not surprised. All
What
right.
do you do? You're going back on what you just said. You loved the rib design before.
Oh, it's unique. I said it's unique. All right, let's move on to the next point. Is 3D printed structures, is that simple? Matt, you get to go first on this one.
No, it's complex. So therefore, design is not simple. It's like the actual designing of the structure is harder because you have to know, okay, what are the tolerances of the material? What angles can I go at? The quality control is much higher. And like if you're trying to build on site, like I mentioned, in the rain or snow or something like that, the material tolerance is so small, you can't do that. And unfortunately, you have to build a building. You can't just like wait until the perfect day to do it. I also, if you've never been through the process of building a regular home, let alone a 3D printed one, there's so many permits. We've talked about the permits, but there's so many hoops that you have to jump through in order to get that done. That's complex. It's going to be even more complex when everybody's doing their own thing differently. Dubai's doing it different than China and Europe and wherever else, and nobody's going to be on the same page. All these permits are all over the place and crazy, and you're never going to get them done because it's too complex. Sorry.
Yeah, there's a lot of stuff on the side that we have to worry about, has to be ironed out, absolutely. But if you look at the process that goes into building a set of walls, be they concrete bricks being held up on each other, framed walls that are then insulated and sheathed and sided and drywall, and if you look at that versus the little guy going around like this, and hey, look, walls are coming up. And it's a simplified version of building, no question. There's less to it, and in the end, you get walls with less effort.
I like the idea of the extruder being a little guy. They should put googly eyes on him as he's going around.
Absolutely.
Just keep spitting up my wall, baby.
People have voted, and we got a second donut. All right, 3 out of 5. Up next.
Yes. Whose is it? I can't remember whose turn it is to go first. It's yours,
I think
right?
it's my turn to go first.
Okay, so of course, the next donut is for environmentally friendly. So our 3D printers, our 3D printed structures, environmentally friendly, Aaron.
Well, I mean, there's several things to consider here. There's the things on the side. If there's fewer people on site, that means, fewer people walking around, less trash, less electricity being used, less people coming in and out of the site. And the fact is, like I said, generally speaking, we're talking about concrete printed. There's other things. There's clay printing. There's some metal stuff. But by and large, when we're looking at structures, we're talking about concrete printing. And concrete is a sustainable material. It's not I think I said renewable, and that was not a correct term. Somebody said it's not green necessarily. So it's not fully to that point where it's like, oh, it's good for the environment to build with it, but it is a sustainable material, which not everything that goes into traditional building is always sustainable. So I think it's fairly environmentally friendly.
Yeah, I mean, I think perhaps the actual material is, but you're never going to get to a place where you can live in a house that's only from 3D printed concrete. Like, you're going to need other pieces that go into it. But I think the overall process of 3D printing is a negative impact on the environment. I'll point you to a German Environmental Association UBA report from 2018, where they said 3D print. Yes, that's exactly right. You know them. You're familiar. They said that 3D printing overall had a burdens on energy demands, burdens on poor recyclability, and a huge need for policy action because there's no restrictions in place. There's no policy in place to manage. There's no environmental safeguards for 3D printed construction, aka environmentally unfriendly, bad.
Not according to our audience.
Guys.
Another donut.
Girls. Come on. Okay.
Last one. Final. And potentially in some ways the most important. Are 3D printed structures honest? Matt, fire away.
I mean, they're some of the most dishonest things you could possibly have. Not only because, like I said, the places where these 3D printed structures are actually being put out at somewhat of a scale, like in China, people aren't even living in these buildings. Okay, yeah, they're being created, but they're so opaque about the process, about the habitability, and how much they actually print, that, okay, fine. Look, you're just saying, you can't just say something, it works, and then it doesn't work. That's dishonest. There's no safety standards, that's dishonest. And these are promises that are made, not delivered on, the definition of dishonesty. So it's just not honest.
Well, I don't know about all that. But fact of the matter is, I don't see, none of the images I've seen of 3D print structures look like anything other than 3D print structures. They're not trying to pretend to be something other than what they are. They have the layer lines of 3D printing. They look like concrete. They are in the shape of a habitable space. So I would say that as I look at what I have seen as far as what's come out of 3D printed structures, what has been printed as a structure, I have to say that they look like what they are, and they're not trying to be anything but a 3D printed structure.
Yeah, they look like it, but if you can't live in it, then it's not a house. If you can't do anything, if you can't be in there, if it's not approved to be safe for you to live in, then it's just a fancy 3D printed wall structure. It should belong in a park. This is for kids to play in, run around in.
Oh, you won't live in it, but send the kids in. I see how that is.
No, they can run around for the afternoon. Fine, we'll have a picnic. But they're not going to live in it. I sure as heck won't let I don't have any kids, but if I did, I wouldn't let them sleep in a 3D printed structure, certainly, because it's so dishonest. People get in the vote. Don't forget to vote. No.
People are voting, but they're adding to the yes. So,
yikes.
I think we got to call it. All right. With that, 3D printed structures, 4 out of 5 donuts. Oh, did that just kill you to have to be
contractually obligated
to that? Matt's the guy who plays the sounds also. All right.
That was a good score. Props to you.
Well, that wraps us up. Thank you guys so much for coming and listening to this and being part of the live filming and casting your votes. This really could not happen without you. We'd just be a couple of guys expressing opinions, if that and then that's just like, I don't know. That's not
every
a
other
podcast. You guys set us apart from the other guys. So thank you so much for hanging out with us, and hopefully see you next time.
Yep. Take care. This has been a Trimble Media production. Thanks for listening to Donuts, Design, and Debate. If you have an opinion about our topic today, or if you have an idea for a future debate, we'd love to hear from you. Send us an email at donuts@trimble.com. Hey, and if you got a designer friend who you think would enjoy the show, go ahead and share this episode with them. Thanks again for tuning in, and take care.